Hello, let us look at the properties of a trapezoid. So first, I want you to draw a quadrilateral with a pair of parallel lines. So then, okay, I guess one thing that I can do is I can just do something like this. Assuming that these two sides are parallel, and all I have to do is just simply connect them like this. I guess this is basically what we are looking at. Now, this is called trapezoid, as you can see over here. Now, definition of a trapezoid, actually we have two schools of thought. First, it would have been this. Trapezoid is a quadrilateral with only one pair of parallel sides. That's the first definition, and many people follows that definition. But at the same time, I just want to recognize that there's a second definition also, which would have been a quadrilateral with everything same up to this point, at least one pair of parallel sides. Now, I understand in this case each one will give us a little bit different point of view, especially when we're getting into parallelogram. But for now, we will loosely understand that the trapezoid has at least one pair of parallel sides. That's what we're gonna assume. All right, then let's move on to the second part here. Knowing that, if line L and line M are parallel, as you can see over here, then how do you find the value of x? Okay, so why don't you try to work on that for a second? That's right. So as you were thinking, here, since this is 60-degree angle, I can move this one over to the other side here, which makes supplementary angles. Now, so therefore, x must be equal to 180 minus 60, which is equal to 120 degrees. All right, then knowing that, how about in a trapezoid? Did you realize that what we have done here is essentially the same thing as what's going on the left side of the trapezoid? That's right. Since some of these two angles are equal to 180, we can apply the same idea here. Then we end up getting x plus 70 is equal to 180. Then x, by subtracting 70 from each side, we get to realize 110 degrees becomes our answer. Now, from here, one thing that which we can think about is, since the trapezoid is made with one pair of parallel sides, then you can see that here we have one pair of angles. We used to call this one as the interior angles on the same side in parallel lines, but one side of the angles and then the other side of the angles, they are all add up to 180. So one of the property that which we can write it is this: interior angles between two parallel sides on the same side are supplementary. So that's one of the property which we get to realize here. All right, now how about the next question? We're going to assume that now then we have an isosceles trapezoid. One thing about isosceles trapezoid here is that from regular trapezoid that we see here, but non-parallel sides has to be congruent. That's what makes isosceles. All right, then, and then they told us that AB is congruent to DC. We want to prove that triangle ABE is congruent to DCF. All right, so then we already know that the pair of sides are congruent and pair of the angles are also congruent. Then what is the third condition that we will be needing? Did you notice that here that these are BE and CF, they are perpendicular to one of the base. That makes BE or CF are the distances between two parallel lines. But since distances between two parallel lines are the constant, so we get to realize that these two must be also equal to each other. Then you can see that between two triangles that which we were looking at originally, we have side and another side, and angle is outside. We call this one as 8 by HL, hypotenuse leg. We can say these two triangles must be congruent. Now, that's what we can do. So let's try to write that up. All right, so here it goes. All right, statement and regions. First, we're going to write down ABCD is trapezoid. So what if I were to sketch the trapezoid and then write down T? And also we know that AB is congruent to CD, and those are all givens. All right, then how are we gonna say that these two triangles are congruent? Now, one other thing which we can do, as we have mentioned, was that actually another thing that I forgot to mention was BE from the given. I should have write it as BE and CF are altitude. So what I'm going to do is I'm going to write that as a part of the givens. All right, then let us move on here to an angle AEB and angle DFC are right angles. Why? Because altitude form right angles. Now step number 3 now becomes the angle AEB must be congruent to angle DFC. Why? All right angles are congruent. All right, let's move on to step number 4. So here what do we get? Also, BE is congruent to CF. Why? Because distance between parallel lines are congruent. Now then we have to talk about parallel lines. So I'm going to mention the BC and AD are parallel. So number 5. Actually, it would have been better if I had to write this one earlier before number 4, but it's a little bit out of sequence, but it's okay. BC is parallel to AD. By definition, of a trapezoid. Meaning they have one pair of sides that are parallel. Now, number 6. So then we have everything. So we can say triangle ABE is congruent to triangle DCF. The regioning here would have been hypotenuse-like in a right triangle. Now, so once we have done that, then I want you to look into this one together. Because we have two congruent triangles, so we can say angle A and angle D are congruent. Why? Because they are by CPCTC. So that's another property which we get to realize. That is, base angles of isosceles trapezoid are congruent. Isosceles trapezoid. Alright, now that's another property which we have to realize. Let's move on to the next one. Knowing the fact that base angles are the same, can we prove that ABCD is, given that ABCD is an isosceles triangle with the givens, can we prove the triangle ABD, which is that triangle, has to be congruent to DCA? So red triangle and blue triangle has to be congruent to they have to be congruent to each other. But you can easily see that first AD is common in both. And we also just mentioned that angle BAD and then CDA are congruent. Why? Because of the base angles in isosceles triangles are congruent, which we just proved it earlier. Now by the givens, we know that these two sides are equal to each other. Then I guess we can say that those two triangles that we have mentioned earlier must be congruent by SAS. So let's try to write that up. Statement and then regions. First, ABCD is an isosceles trapezoid. And then AB is congruent to DC. And all these things are givens. Let us move on to the second one. Then here we get AD is congruent to AD. Why? Because reflexive. Step number 3. Then angle BAD must be congruent to angle CDA. Why? Because base angles in isosceles trapezoid are congruent. And we just talked about that earlier. So therefore, I think we have about everything that we need. So statement number 4, we can say triangle ABD must be congruent to triangle DCA by SAS postulate. Alright, now, then why did I write this one down so far? Because this will give us the hint on how BD and then CA must be equal to each other, because those are part of the two congruent triangles, and then by CPCTC, those two blue line segments are congruent. That tells us that diagonals are congruent. So this is the second figure that has diagonals being congruent besides the rectangle. And of course not assuming the squares either. Then here let us organize the properties here. First definition of the trapezoid is a quadrilateral with a pair of parallel sides. Alright, now so from here, one of the property that we realized was interior angles between parallel sides on the same side are supplementary. So that's what we have to realize about the trapezoid. But if soon as we see isosceles trapezoid, now of course all these things are still true. But if I have to add one more thing, addition to the definition here, non-parallel sides are congruent. That's one thing that which we get to realize. And then diagonals diagonals are congruent. That's another property that which we just realized. And lastly, base angles are congruent. So these are some properties that which we should know about the trapezoid, and then also isosceles trapezoid. All right. Now let's look at one example here. We have isosceles trapezoid. We have all four sides are given to us in this manner. Then what do you realize? That's right. Since it's an isosceles, non-parallel sides has to be congruent to each other. So then we can write it as 3x plus 2 must be equal to 2x plus 5. So subtracting 2x, then we get x plus 2 equals 5, then x must be equal to negative 3. Now, find the value of x. We just did it. Okay. Next question. Here we have, we need to figure out the measure of these two angles. Since AD and BC are congruent, we can say that these two, this must be isosceles trapezoid. That means this angle is same as this angle, but between these two angles they are supplementary. So the equation which we can write it is 3x minus 15 plus 4x plus 20 must be equal to 180. Then we get 7x plus 5 must be equal to 180. So x must be equal to 7x must be equal to 175. And when you divide by 7, x must be equal to 25. So, but 25 is not my answer because I'm looking for angle D, but that can be changed from by plugging in 25 into x for angle C because they must be the same angle. So we get 3 times 25 minus 15. So here we get 75 minus 15 becomes 60. So therefore our answer is 60. Alright, so these are the simple application of the trapezoid, and we'll stop here, and I'll see you later. Bye-bye.